Voltage, vitality, elevation.
Beneath the veil of clouds, where storms coil and unravel. Under the oceans, where saltwater conducts unseen currents across entire basins. Far below the continents themselves, anchored to slow-moving plates, resting above rivers of molten metal. Our planet is humming, not audibly, but electrically. Every second of every day, Earth resonates with an invisible pulse, a global electromagnetic rhythm born from lightning, guided by the planet's magnetic field, and trapped between the surface of the world and the charged edge of space itself. This pulse does not come from a single storm or a single place. It is collective, worldwide, continuous. More than 8 million lightning discharges each day inject energy into the atmosphere, each one sending electromagnetic waves racing around the globe at nearly the speed of light. Most of that energy fades into silence, but a small portion does not escape. Instead, it is caught between the conductive surface of the Earth and the ionosphere, a vast electrified shell sculpted by solar radiation. Within this planetary cavity, certain frequencies reinforce themselves, overlapping again and again until standing waves form. The planet begins to ring. The strongest of these resonances settles at a frequency of 7.83 Hz, a wavelength so long it wraps around the Earth itself. It is not broadcast, it is not transmitted, it simply exists, sustained as long as thunderstorms produce lightning. This is not a metaphor, nor is it mysticism. This is pure physics, a natural consequence of a rotating conductive planet wrapped in plasma and energized by storms. For decades, scientists have measured this faint signal, barely detectable, yet unmistakable, rising and falling with global lightning activity, shifting subtly with solar storms, and persisting through day and night, season after season. They call it the Schumann Resonance, a phenomenon predicted before it was ever measured, a frequency older than civilization, the very signal that has never stopped since the atmosphere formed, producing storms and causing lightning to strike for the first time. It is often called the heartbeat of the planet, not because it thinks or feels, but because it is constant, rhythmic, and inseparable from the systems that make Earth alive. Together, we'll journey into those unseen systems of our majestic planet. From the molten depths that generate Earth's magnetic field, into the electrified skies where storms and space collide, and get an understanding of the subtle frequencies that bind atmosphere, weather, and planet into a single resonant whole. This is the story of an Earth that is not silent, but electrically alive. And this hum, this quiet, persistent rhythm, is the sound of a living planet in motion. To understand Earth's electromagnetic voice, we must begin far below the surface, far beyond the reach of sunlight, beyond the roots of mountains, and the deepest scars of tectonic fracture. Deeper than magma, even deeper than memory itself. We must descend into the core itself. At the very center of the planet lies the inner core, a dense, solid sphere of iron and nickel, nearly 2,400 kilometers across. Its temperature rivals that of the Sun's surface, exceeding 5,000 degrees Celsius. Yet it remains solid, locked in place by pressures so extreme they crush atoms into rigid alignment. This is not stillness, it is a restraint. Surrounding the inner core is something far more restless. The outer core, a vast global ocean of molten metal over 2,200 kilometers thick, composed primarily of liquid iron alloyed with lighter elements. Here, heat escapes outward from the inner core, setting the liquid metal into constant motion. It rises, cools, and sinks again. Massive convection currents roll endlessly through this metallic sea, while the planet's rotation twists those flows into spiraling columns, aligned with Earth's axis like invisible gears turning deep within the Earth. This liquid iron does not sit still, it's in constant motion, and when an electrically conductive material moves inside a rotating body, something amazing happens. As the molten iron flows, it drags charged particles with it. Those moving charges generate electrical currents, and wherever electrical currents exist, magnetic fields are born. These magnetic fields, in turn, reinforce the currents that created them. A feedback loop emerges, self-sustaining, self-organizing, relentless. This process, known as the geodynamo, is not powered by machinery, but by heat, motion, and time. It has operated for billions of years, turning Earth itself into a colossal electromagnet. The result is a magnetic field that erupts from the planet's interior, threads through the crust, and expands outward into space, far beyond the atmosphere, forming an immense, invisible shield known as the magnetosphere. This magnetic cocoon deflects the solar wind, a ceaseless torrent of charged particles streaming outward from the sun at millions of kilometers per hour. When those particles collide with Earth's magnetic field, they are diverted, guided, and trapped, prevented from scouring the atmosphere away molecule by molecule. Without this shield, Earth would not merely be hostile. It would be unrecognizable. The atmosphere would erode into space. Oceans would slowly vanish. Radiation would bombard the surface unchecked. Life, as we know it, would never have taken hold. Mars offers a warning, a world that lost its magnetic field, and with it, its protection. Earth survived because its core never stopped tuning. But this magnetic field does more than defend. It connects. The magnetosphere stretches tens of thousands of kilometers into space, interacting directly with the sun, flexing and compressing under the pressure of solar storms, storing and releasing energy on a planetary scale. Electrical currents flow not only beneath our feet, but above our heads, linking Earth's interior to its atmosphere, and its atmosphere to space. In this way, the same force that shields life also binds the planet to the cosmos. What if the magnetic field is not just Earth's armor, but its handshake with the universe? Earth's atmosphere is more than just clouds and air. It is layered dynamically and, critically, electrified. What we breathe is only the thinnest, lowest fraction of a far more complex structure. As altitude increases, the atmosphere transforms. Pressure drops, temperatures shift, and eventually, sunlight itself begins to change the nature of matter. High above the realm of clouds and storms, beyond the reach of weather, intense solar radiation bombards the upper atmosphere. Ultraviolet light and X-rays strike atoms with enough energy to tear electrons free, converting neutral gases into charged particles. The result is the ionosphere, a vast, shimmering shell of plasma encircling the planet, stretching from roughly 60 kilometers above the surface to more than 1,000 kilometers into space. Here, the atmosphere conducts electricity. Its density rises and falls with daylight and darkness, swelling under solar storms and thinning during quiet periods. It is shaped by the sun, sculpted by Earth's magnetic field, and constantly in motion. Below this charged ceiling lies the other half of the system, the surface of the Earth itself. Oceans rich in dissolved salts act as immense conductive sheets. Continents are threaded with mineral veins, groundwater, and metallic ores. Even solid rock, under pressure and heat, can carry electrical currents. Taken together, the planet's surface forms a global electrical ground. Between these two conductive boundaries, the ionosphere above and the Earth below, exists something extraordinary. A planet-sized electromagnetic cavity. It wraps completely around the globe, following Earth's curvature, enclosing every ocean, mountain range, and even cities and forests within a single resonant space. This cavity is anything but empty. It is alive with energy. Every thunderstorm becomes a generator. Every lightning strike releases a powerful electromagnetic pulse that spreads outward in all directions. These pulses race through the cavity at nearly the speed of light, hugging the surface of the planet, reflecting between ground and sky. At any given moment, thousands of storms are active somewhere on Earth. Their combined activity creates a continuous, global flow of electromagnetic energy, an invisible circulation linking distant continents through the atmosphere itself. Most of these waves are chaotic. They interfere, they cancel, and fade into the background noise of the planet. But some do not. Some wavelengths fit the dimensions of the Earth with uncanny precision. They reinforce themselves, circling the globe again and again, growing stronger instead of weaker. They remain, suspended between the Earth and the edge of space, waiting to be heard. Lightning is not rare. It is constant. Every day, Earth experiences approximately 8.6 million lightning discharges, a ceaseless storm of electrical release unfolding across the planet's surface. That is nearly 100 strikes every second, occurring somewhere on Earth at all times, whether seen or unseen. The planet never stops flashing. Yet most lightning is never witnessed by human eyes. Roughly 3/4 of all lightning events occur within clouds or between clouds, vast hidden exchanges of electrical charge taking place inside towering storm systems that stretch kilometers into the sky. These intra-cloud and cloud-to-cloud discharges silently rebalance the electrical structure of the atmosphere, shaping storms from the inside out. Only about 1/4 of lightning bolts ever reach the ground. These are the strikes we notice, the blinding flashes, the thunderclaps that follow, but they represent only a fraction of Earth's true electrical activity. Each discharge lasts mere milliseconds, but within that fleeting instant, extraordinary forces are unleashed. A lightning channel superheats the surrounding air to temperatures exceeding 30,000 degrees Celsius, hotter than the surface of the sun, causing the air to expand explosively. This violent expansion generates shock waves that tear through the atmosphere, producing the rolling crack of thunder that can travel for miles. At the same time, lightning releases a burst of electromagnetic radiation spanning nearly the entire spectrum, from radio waves and visible light to X-rays and gamma rays. It is one of the most powerful natural particle accelerators on Earth, and hidden within this chaotic explosion of energy is something far more subtle. Embedded in every lightning strike are extremely low-frequency electromagnetic waves, ELF waves, with wavelengths so vast they can stretch tens of thousands of kilometers. These waves move too slowly and are too long to escape into space. Instead, they remain trapped. They slide along the curvature of the planet, reflecting between the Earth's conductive surface and the ionosphere above. They circle the globe again and again, barely losing energy as they go. Each lightning strike adds to this global circulation, reinforcing some waves, canceling others, feeding energy into the planet's electromagnetic environment. Over time, order emerges from chaos. The Earth itself becomes part of the circuit, a resonant chamber on a planetary scale. What happens when a planet becomes its own resonant instrument, continuously struck by storms and lightning, endlessly ringing through space? At first, the electromagnetic waves released by lightning are chaotic. They surge outward in all directions, overlapping, colliding, interfering, an invisible storm layered atop the visible one. Most of this energy disperses, fading into background noise as waves cancel one another out, but the planet itself imposes limits. Earth is not infinite, it has boundaries. Below lies a conductive surface. Above, a charged, reflective ionosphere. Between them, electromagnetic waves are forced to travel a confined path, around the curvature of the planet, hugging the globe like ripples trapped inside a spherical shell. As these waves race around the Earth, they begin to interfere with each other. Some arrive out of phase, crest meeting trough, and vanish. Others align, crest reinforcing crest, growing stronger with each circuit. Only certain wavelengths survive. These are the waves whose lengths fit Earth's circumference with remarkable precision. Waves that complete a full journey around the planet and return in phase with themselves. Waves that do not cancel, but lock in. This is the moment chaos becomes structure. A standing wave forms. Unlike a traveling wave, a standing wave does not move across space. Instead, it oscillates in place, its peaks and nodes fixed relative to the planet itself. The energy remains trapped, rhythmically pulsing between Earth and sky. This lock-in is not imposed, it is inevitable. The size of the Earth, the height of the ionosphere, and the speed of light together dictate which frequencies can exist. All others decay. The strongest and lowest of these locked frequencies settles at approximately 7.83 Hz. a wavelength so vast it wraps around the planet nearly 4 times. Higher harmonics follow, stacking above it like faint echoes. As long as lightning continues to strike somewhere on Earth, these standing waves are continuously re-energized. They do not need a single storm to persist. They are sustained collectively by the planet itself. The Earth becomes more than a source of energy. It becomes a resonator, a natural electromagnetic cavity tuned by its own dimensions, rings softly but endlessly through the space it occupies. This is the inner workings of the Schumann Resonance, not a broadcast, but a signal sent outward, a planetary vibration, locked in place, maintained by storms, and woven into the electromagnetic fabric of the world. The Schumann resonance was discovered in 1952 by German physicist Winfried Otto Schumann, who proposed that the Earth should resonate. If a planet can resonate, what else might be shaped by the rhythms it never stops producing? The human brain is an electrical organ. Every thought, every memory, every sensation arises from the movement of charged ions across billions of neurons. These electrical impulses do not fire randomly. They organize themselves into rhythms, patterns of collective activity that neuroscientists measure as brainwaves. These rhythms span a wide range of frequencies. Delta waves dominate deep and dreamless sleep. Theta waves appear during drowsiness, memory formation, and imagination. Beta waves accompany active thought, problem-solving, and alert attention. And between them lies the alpha band, a frequency range often associated with relaxed awareness, quiet focus, and the calm alertness felt during meditation or creative flow. At its lower edge, the alpha band overlaps a familiar number, approximately 7 to 8 Hz, the same range as Earth's fundamental Schumann resonance. This numerical proximity has inspired decades of speculation, some careful, some wildly exaggerated. Claims have emerged suggesting synchronization, entrainment, and even influence over consciousness itself. But science urges restraint. The electromagnetic fields associated with the Schumann resonance are extraordinarily weak at Earth's surface, many orders of magnitude weaker than the fields produced by the brain itself, household electronics, or even the electrical activity of nearby muscles. There is no credible evidence that the Schumann resonance controls human thought, alters emotion, or entrains brainwaves in any direct or deterministic way. Correlation is not causation. Numerical similarity is not proof of influence. Yet dismissing the subject entirely would also miss something important. One fact remains undeniable. Life on Earth evolved inside this electromagnetic environment. From the first single-celled organisms to complex nervous systems, biology has never existed in the absence of Earth's natural fields. The Schumann resonance was already present long before brains evolved to measure anything at all. It is not a signal sent to us. It does not carry information. It does not instruct the brain. It is a background condition, part of the physical context in which life emerged, adapted, and diversified, like gravity, atmospheric pressure, and the steady pull of the planet beneath our feet, invisible and constant, so fundamental that we rarely notice it at all. The sun is not silent. It roars in wavelengths we cannot hear, and flashes with violence we cannot see. Beneath its glowing surface, colossal magnetic fields twist and tangle, storing immense amounts of energy. When that tension becomes too great, it is released in sudden, explosive events, solar flares, bursts of radiation that can outshine entire regions of the sun in seconds. At times, these eruptions are accompanied by something even larger: coronal mass ejections, vast clouds of electrified plasma, billions of tons of charged particles torn from the sun's outer atmosphere and hurled into space at millions of kilometers per hour. These storms expand as they travel, filling interplanetary space with magnetic fields and high-energy ions. When such a storm reaches Earth, it does not strike the surface directly. It meets the magnetosphere. Earth's magnetic field compresses on the sunward side, its invisible boundary pushed inward like a shield absorbing a blow. On the night side, The field stretches into a long magnetic tail, storing energy that is eventually released in powerful surges. The magnetosphere shudders. Electrical currents intensify. Field lines reconnect. Energy cascades toward the planet's poles. There, charged particles are guided along magnetic pathways, spiraling downward into the upper atmosphere. As they collide with atoms of oxygen and nitrogen, energy is transferred and electrons leap to higher states. When they fall back, light is released. The sky ignites. Green curtains ripple. Crimson arcs bloom. Violet and blue flicker at the edges of vision. These auroras, the northern and southern lights, are not mere spectacles. They are physical evidence of an electrical exchange between Earth and its star, a visible signature of energy flowing across millions of kilometers of space. But the effects do not stop at the poles. Solar storms heat and expand the ionosphere, altering its density and conductivity. Radio signals bend differently. Satellite orbits change subtly, and the electromagnetic cavity between Earth and sky is reshaped in real time. Planetary resonances respond. The Schumann resonance does not vanish, but its amplitude, clarity, and harmonic structure can fluctuate as the ionosphere rises and falls, as geomagnetic storms ripple through the system. This is space weather, a dynamic, ever-changing influence that links solar activity to Earth's electromagnetic environment. The connection is constant. The sun emits, and the Earth responds. In this relationship, Earth is not passive, it resonates. If the sun can alter the way our planet rings, what does that say about our place inside a living solar system? The sun plays Earth like an instrument, and the music never truly stops. Earth is never truly quiet. Beneath the noise of civilization, beneath wind, waves, and flowing magma, the planet hums with a rhythm older than life itself, a resonance born of lightning and sky, shaped by magnetism, tuned by the sun. It doesn't command us. It speaks not in words, but in a constant rhythmic frequency. It simply exists, steady, global, eternal. A reminder that we live on a world that is not inert, but alive with motion, energy, and connection. And as long as storms flash somewhere on Earth, as long as the sun shines, our wonderful planet will continue to sing its eternal song. Thanks so much for watching. Zap the like button and subscribe to the channel so you don't miss a thing. What do you think about the Schumann resonance frequency of the Earth? Let me know what's on your mind in the comments below. Stay curious, stay grounded, and as always, stay elevated.
Thanks for watching Voltage Vitality Elevation. Please select one of the videos displayed on the screen to continue watching.